students, welcome to the lesson. The topic is thermal expansion. What is thermal expansion? When we heat an object, its size increases. This increase in size of an object on heating is called thermal expansion. Today we will discuss the two types of thermal expansion. One is the linear thermal expansion and other is the volumetric thermal expansion. Let us discuss them one by one. First, we take linear thermal expansion. Students, increase in length of an object on heating is called linear thermal expansion. Students, this change in length on heating an object is proportional to two things. Number one, its original length. How much the object is originally long, longer objects will expand more and short objects will expand less. Secondly, it depends upon the change in its temperature. Means if we heat the object with less amount, it will expand less, and when we heat it more, it will expand more. If rise in its temperature is less, it will expand less. If rise in its temperature is more, it will expand more. So these two things are written here mathematically. Change in length, delta means small change in length, is directly proportional to original length. More is the original length, more will be the change in length on heating. Similarly, this change in length is proportional to change in temperature. More is the change in temperature, more will be the change in length. Now combining these two facts in a single equation, we get a relation like this. Delta L equals to alpha L naught delta T. Actually, we removed the sign of proportionality and we placed a constant alpha. Alpha is constant of proportionality and it is called coefficient of linear thermal expansion. Its value is different for different materials. So the objects of different materials will expand differently for same length and for same change in temperature. So alpha depends upon the material of that object. It is called coefficient of linear thermal expansion. So here we obtained this equation. Change in length is equal to alpha L naught delta T. Now students, let us consider a rod whose original length, means length before heating, is L naught, and after heating its new length is LT when it is heated through temperature T. So temperature at 0 degree centigrade, its length was L naught, and at T degree centigrade its length is LT. So what is the change in length? This change in length is equals to final length at higher temperature T, LT, minus length at 0 degree, L naught. So longer length minus shorter length will give you the change in length, or you can say final length minus initial length, or length after heating and length minus length before heating. This will give you the difference in the length or increase in the length. Putting this value here, what we get? We get the relation like this. LT minus L naught equals to alpha L naught delta T. Taking this L naught on the right side, we get equation like this. Length at temperature T is equals to original length plus alpha L naught delta T. Taking this L naught common in this equation, here we get the result for length at higher temperature is equals to LT into 1 plus alpha delta T. I told you alpha is called coefficient of linear thermal expansion and its value is different for different materials. Now student, what is volumetric thermal expansion? Increase in volume of an object on heating. When we heat an object and its volume increases, then it is called volumetric thermal expansion. Again, this change in volume is proportional to original volume and change in temperature. Bigger an object, more it will expand, and more is the change in temperature, more will be the expansion. Means change in volume depends upon the original volume. Bigger objects will expand more. And what is the rise in temperature? If we change the temperature more, the object will expand more. Mathematically, this relation is given by this equation. Change in volume is directly proportional to original volume, and change in volume is directly proportional to change in temperature. Bigger the object, more is its volume, more it will expand. More is the change in temperature, more will be the change in volume, more will be the volumetric thermal expansion. Now combining these two facts in a single equation, we get relation like this. Change in volume is directly proportional to original volume and change in temperature. Now again, replacing this sign of proportionality with sign of equality. What we get, sorry, change in volume is equals to beta V naught delta T. Again, when we replaced sign of proportionality with sign of equality, we multiplied on the right side with a constant that is called coefficient of volumetric thermal expansion. Beta is coefficient of volumetric thermal expansion. Now students, let us consider the example of an object whose original volume is V naught. When it is heated through temperature delta T, its volume becomes Vt. So V naught is the volume at 0 degree centigrade and Vt is the volume at T degree centigrade. Now what will be the change in volume? This bigger volume minus the initial volume. Volume after heating minus volume before heating. So this will give us the change in volume. Putting this value of change in volume in this equation, what we get? Vt minus V naught is equals to beta V naught delta T. Rearranging the equation, Vt, taking V naught on the right side, V naught plus beta V naught delta T, taking V naught common, and we get the final equation for volume of an object at temperature T after heating is given by the equation V naught 1 plus beta delta T, where beta is the coefficient of volumetric thermal expansion. Students, its value is different for different materials. Different materials expand differently for the same size and for the same change in temperature. So beta also depends upon the nature of the material. So this is how we calculate the volumetric and linear thermal expansion of solids. I hope it is clear. Students, thank you for sparing your time to watch the video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.